Hi, Matt. This is Chandra. I had a quick question.
Sure.
So, why or when really is the question? Do you recommend RStudio versus Anaconda versus Jupyter Notebook? Is that would be nice for me to know.
Yeah, that's fine.
And then I'm going to throw in SAS Studio as well because I get asked that question.
Sure. To answer your last question first, I honestly have never used SAS. It's my understanding that it's part GUI, part coding. Is that correct? Have you used it before?
I'm sorry, it's part what?
GUI based, so kind of like what you're used to with Windows, where you're using a mouse and clicking through menus. But
Yeah,
there is
but I'm
coding.
I'm saying from a data science perspective and from the perspective of data analysis. There's Python, just Python, and then using NumPy and Pandas is big enough. And
Yeah.
then what do these different environments bring, and why do we have communities around the studios and not around just NumPy and Pandas?
Well, so really quickly with the NumPys and Pandas are an add-on package to Python. The two differences would be, would you rather use Python or would you rather use R? And it's just they're two different programming languages. And that's really based on personal preference. I would say the biggest differences between Python and R are R was written specifically to perform data analysis tasks, where Python was written as a programming language to do lots of different things, but it can also do data science. I personally like R better. I think it's a more logical language for me to use, and the reasons I use programming language is more for data analysis. I don't really use it for anything else. Now, if you want to go through and scrape websites, R is not very good for that. Python is a better use for it, and they can be used in conjunction with each other. Now, the second part of your question is asking about using the Python versus, or I'm sorry, using things like Anaconda versus using something like RStudio or Jupyter Notebooks. The first part of it is Anaconda creates an environment. So it's not actually a it's not actually an interface to use in itself. What it does is it says if you're using Python, here are the essential packages for using Python. When you download and install Anaconda, it's going to install all these packages for you already. And it does that with Python because Python is not really the easiest install to do, to install additional packages. It's a little bit more, you have to know a little bit about using Bash and Terminal to really install it. So basically what that does, and the other thing with Python is it doesn't have the consortium that R does. So what R will do is with all these add-on packages, they have a consortium that vets them to say these are safe to use, these are doing what the functions with them say that they can use. Python is a little bit more Wild West. That's why you might see stories of malicious packages with it. So what Anaconda does is it vets it for you and it says these are the good packages to use. The second part to that question is what's the difference between RStudio and Jupyter Notebooks? RStudio can read and write both Python and R language. It is focused on R language. To run Python in it, you have to do a little, it has to load up a package that's called reticulate or something like that, but it will load it up for you. But RStudio mainly wants to use R language, and you could also use Python. Jupyter Notebooks doesn't read R language, it only reads Python, so it'll only load up a Python kernel for it. So they are two different programs. If you think about it, like Excel versus SPSS, right? They're two different things that they do essentially the same functionality. SPSS, I know, is more advanced. Or even better, think about it, Microsoft Edge versus Google Chrome if you're using a browser for it. They'll just do particular things on their own. So it's how you like things to look essentially. There's also VS Studio, I believe is the Microsoft coding apparatus, our coding and our interface that you can use. And it essentially just puts a layer over these programming languages. So if I share really quickly, I can show you. If you were using R without RStudio, you could do it, and this is what you'll get. This is everything that you'll get with it. And right, we could do library tidyverse, and we could load up the tidyverse library. We could set WD, or let's just do get WD because I don't feel like we could say here's the current file folder that we're in, but it's not really an environment where RStudio will give you, okay, here's all the labels that you have, here's the current file folder, right? It puts a layer over R that it allows it to be easier for you to use. Same thing with Jupyter Notebooks. You could load up Python on its own. It looks almost like identical to this, but it's not really anything that you could save. You could save your workspace, but you could kind of create these scripts, but they're not as nice looking and they're not line numbered and all that stuff. So what I liken it if you know if you're familiar with DOS or if you use DOS before the Microsoft Windows days, it's the difference is DOS would be running R and Windows would be running RStudio. It allows a little bit more GUI graphical interface. It allows you to see what's going on in your environment a little bit more um, for it. And so does that help answer your question?
Yes, it does. Thank you so very much.
And it looks like we got a lot of people that have come in, so I think we can go ahead and get started with the session for today. So, like I said, for people that haven't come in yet, this is, if you've been to the other workshops, this is a shorter one. We will talk about how you create data visualization plots within RStudio using R. And after that, I will talk briefly about creating an RMarkdown file. So if you're interested in, we've been using our script files the whole time. Those are code focused files. So everything that you type into there, R is going to be interpreting as code unless you tell it otherwise. Our Markdown files does the reverse. Everything that you type in there, it does not interpret as code, but you can put sections into it for coding. This allows you to do a couple things. You can write up your paper right in RStudio and have the code dynamically change with it. So you're not copying and pasting it back from Microsoft Word, or if you don't have Microsoft Word, the license for it, you can just write it up in RStudio. All right. So let's go ahead and get started. So again, my name is Matt Steele. I am one of the research services librarians here at the university. I'm joined by Jeff Worst. Jeff is a science-focused instruction librarian. If you have any questions while this is going on, feel free to ask. Jeff can help you out with some technicalities. Jeff is also going to be monitoring the chat, so you can already see he's put in the link for the GitHub that we will be using for this. If you haven't added the lesson plan for today, go ahead and do so now. You should have got instructions for it, but if you just didn't have a chance, please go ahead and do it. So you have all the files available to you. As we are going on, I just want to make a couple notes. This is the last workshop in this series. So we did introduction with our first steps. We did data cleaning during the last session, and today we'll finish up with data visualization. You can find all of our workshops by going to the library's website, and under the fall lineup for workshops, you can see what you have available to you. If you are focused on data services, you can click on category and go to data services and click search and see all the workshops we are offering on it. I will note Thursday, so in a couple of days, we've used GitHub to download the lesson plans. Or if you are interested in using GitHub, it is a version control software that allows you to store and track changes within your code and revert your code. And it is a really great service, especially if you're doing collaborations a lot with your coding or if you are working on multiple computers, you want to have access to your code at all time. So Thursday, we're actually doing a workshop for an introduction to using that. And then we are also rerunning all these workshops again in October. So if you want to attend them again. They are available beginning October 9th. Same format that we did with these ones. All righty. So once we're ready, let's go ahead and get started with data visualization. So data visualization uses one of the tidyverse packages that is called ggplot. It is the easiest to use. And one thing I haven't noted on as we've kind of been talking about this, I have noted that, right, documentation is very important when using programming languages like R because that's where you'll go to see what functions are available to you. And Tidyverse, I think, really does a great job with this documentation with it. One thing, though, that they do that I haven't noted, but it's a feature that I really like, and I think it's best used with ggplot, is they provide these little cheat sheets in their documentation page. So if you see under here, they have their cheat sheet. What this will do, and what I really like it for ggplot, is, let me just download this and open it up so it's easier to see. What this will do is it'll say, here are the major functions within this package, and here's how you use them. Now, what's great with ggplot is you're going to be telling R a lot of the time, this is the type of shape I want to make. I want to make a scatter plot. I want to make a histogram. I want to make a box plot. I want to make a line plot, so on and so forth. What this cheat sheet will allow you to do is to see the functions that allow you to create all these. And what they've actually done, they've gone one step further and they've said, hey, what type of variables are you working with? Are you using two variables that are both continuous? You might want to try out these plots to visualize the data that you have used, so on and so forth. I'm using one discrete and one continuous. Oh, a box plot might be what you are trying to use with this. So it is just one thing that I would suggest really taking a look at as you start to build up these various things. And then as we start talking about things like scales and stats, you can see how to use them within them are the themes that are available to you. Just a quick reminder too, as you are working on this, R is iterative learning. So you only get better at it the more you use it, and you only become more used to how it works the more you use it. So I highly suggest if you are working on projects, try running it through R. Try doing some of the data cleaning through R's. Try doing some of the data visualization through R. Just if anything to get you practice, and then work through the documentation as you are doing it, because that will give you the ideas of how to do these various things. And then the library has a database that is called the O'Reilly Learning Platform. That is a great one to use for learning these soft skills as you're going through your as you are going through your scholarship. So the one I really suggest for using R is R for Data Science. I think it's a very good book, and they have lots of examples of how to do visualization within it. And then just a recap of what we've done so far. Functions are how you provide commands within R. Arguments within functions are how you tell the function to run. And objects are how you store information. And then always remember to run your code. So when you type something into your script, it won't run until you actually run the code. You can run it with either the run button or control enter on PC or command return on Macs. All right, so let's go ahead and get started. On your own computer, go ahead and open up RStudio. And then set the working directory. A reminder of how to set the working directory is first we're going to start a new file. So we're going to go to File, New File, our script. Then we're going to go into Session, Set Working Directory, choose Directory, and find the file on your computer where you saved the lesson plan for today, or the file folder. So mine is in our projects, and it is in Data Visualization Online. And then go ahead and open that. If you've done it correctly in your console pane, you should get the command line setwd and the right file path for that. If this is a script that you would be working on for a long time, I would suggest saving that setwd command into your script. And while you guys work on that, I'm going to go ahead and zoom in a little bit. And once you're ready to move on, once you have your working directory set, go ahead and raise your hand. So again, we are creating a new file under File, New File, our script. And then we are setting the directory under Session, Set Working Directory, Choose Directory. Then you'll just need to, on your computer, find where you downloaded the lesson plan for today. And if you have any questions, please feel free to ask in chat or unmute and ask.
So I followed your instructions and downloaded RStudio. And when I do session, what do I do? Session set working directory, nothing shows up.
So we go into Session, Set Working Directory, Choose Directory, and then it should open up File Explorer. Is that
Yeah.
happening? And then you chose the folder that you downloaded the lesson plan into? I'm sorry, did you download the lesson plan?
The lesson plan, yeah.
Okay, so you'll just need to find that full file folder that's downloaded to. If you are unsure, if you open up GitHub, if you went through GitHub Desktop to clone the repository, if you go in there and you go into File, Clone Repository, down here at the bottom, it should show you the main directory that it's saved to. So mine's right now defaulting to my R projects.
So do that on GitHub. Okay.
That will just give you an idea of where you saved it to.
Okay. I'm just going to follow along and I'll watch the recording again.
Okay, sounds good.
I basically did your instructions for 2 workshops. And so now I have Anaconda, I have GitHub and this, and I have
Yeah,
2 GitHub repos. So
yeah, it gets a little.
I'll just do this later. Thank you.
Okay, sounds good. All right, next thing we're going to do then is load up ggplot. So as I mentioned, ggplot is a package that is part of the tidyverse collection. So to load up ggplot, we are going to load up the tidyverse package, and we're going to use the function library to do that, and then the name of the package that we want to load, and we are going to go ahead then and run that line of code. You'll know that the line of code ran successfully if you get this message that it's attached. It's attached and open the various packages. So go ahead and do that now. If you have any questions, please let me know. Once you are ready to move on, go ahead and raise your hand. Okay, it looks like a good bit of you are ready to move along. So let's go ahead. You can lower your hand. And let me talk you through really quickly about how we build a plot using our ngg-plot. So this is going to look a little bit different than the coding that we've done before. Some of it will look the same, most of it will look a little different. But let me just walk you through how this works. The way that it's built is what the creators call the grammar of graph. And so this basically what you'll do when you are building a plot is you'll use your code to add layers to the plot. There are three layers that are required to do this. You have to have the data that you want to visualize. So once you get done cleaning up and transforming your data, you'll need that. You'll need what they refer to as the aesthetic mapping or the AES. This is essentially, at its most simple, this is essentially the variables that you want to use on the axis. But it can also add things like visual properties, position, color, size, and shape. But basically, you need first the data and you need what variables are going to go into the plot. And then you thirdly set what they call the geometric object, but that's the shape of the plot. So these are things like, is it going to be a line graph? Is it going to be a histogram? Things of that nature. You have, in addition to this, the optional layers that you can also put onto it. You could put a coordinate system over it. So you could make it a Cartesian or a polar plot, or you could zoom into certain aspects of the plot within it. You could add a facet layer, which will essentially divide the plots into subplots based on a categorical variable. And you can add themes to it, so things that change the appearance of it. So these will be things like what labels are you attaching to the variables? What labels are you attaching to the plot? Do you want to add a subtitle? Do you want to add a caption? Do you want to add a legend? So on and so forth. There are built-in themes, and we'll take a look at them, but you can also really focus in and change the themes a lot yourself. So the first graph we are going to do is we are going to create a line graph, and we're going to create a line graph that tracks the approval rating for Supreme Court of the United States over time. This data was grabbed from 538 about a year ago, so it's a little dated now, but so the first thing we're going to do with this is something we are familiar with. We're going to create an object. We're going to call this object SCOTUS. Into SCOTUS, we are going to read a file that we have in our folder that is called scotusapproval.csv. And then we are going to limit the SCOTUS approval using the filter. We're just going to limit it to the pollster that's called YouGov. So let me show you how this works, and then I will let you try it out for yourself. So first off, we're going to create the object called SCOTUS, and we're going to read CSV, and we are going to read scotusapproval.csv. And we're going to then run that line of code, and then into our environment, we should have a data set saved into Scopus that has 73 observations on 8 variables. And if I look at this, what the table looks like, we can see we have a variable that's called pollster. And within this variable, we have different pollsters that are actually tracking this. We're just going to limit it to the YouGov. So we're going to change SCOTUS, and we're going to say filter pollster equal capital U, capital G, Gov. So now if we look at SCOTUS, now we're only looking at YouGov as a pollster. So what this line of code said, we're going to overwrite our current data set, and we're going to work on the data set SCOTUS. And within that, we're going to filter pollsters so it only is YouGov. So on your computer, go ahead and clean up the data set like I just did. So you're going to read in the SCOTUS approval.csv file, and then you're going to filter that so it's only YouGov for the pollster. And once you're ready, go ahead and raise your hand and we can move along. And if you have any questions, feel free to ask too.
I have a question.
Yeah,
What if you want to undo what you just did? So for instance, we just filtered the entire SCOTUS data to show the ones that the poster is yoga. What if you want to like control Z that? How do we do that?
that's a great question. So as I mentioned, one of the things when you are creating objects is whatever the last thing you ran on it will overwrite it. So as honestly, I probably should have called this a new object like underscore yuga or a YG. So I didn't overwrite it. But if you want to go back and reload up that data, that's when you would have to go back to your original line where you read the data in and rerun it again. So if I run that again, now I have 73 observations again, so it's the original. So that is how you undo the filter. There's no, unfortunately, Control Z within using R to undo what you just did. You just got to go back, find the line of code that you originally loaded it up, and run the operations up until the point that something messed up. That's why
Okay.
I do say early on in your coding, as you start to get used to it, just create new names for the objects. As you get more and more used to it, you can be fine overwriting what you did. But if you are worried at all, create a new object, and when you're done, you can always go back and clean it up on a singular object. Okay, looks like most people are ready to go ahead and move on. So the first thing we're going to do is we're going to set the plot. So we have our data now. Now we need to set our plot. So this line here, what we are doing is we're going to create a new object. We're going to call it SCOTUS.line. This is a preference for me. This is not something that everybody needs to do. But when I talked back at our first session, naming conventions for objects. One way that you can separate two names for an object is with an underscore. What I like to do when I am cleaning data is I like to use underscore named objects. And when I am creating visualizations, I like to separate the object names with a dot. It's just a personal preference. It's when I look back at my code, I can see that I was easily creating a line graph here, and that's the information I'm storing into that object. So again, these are conventions, but conventions are used to make it easy on yourself. So this is one way I make it easy on myself to understand what's going on. So I'm going to create a new object. I'm going to call it SCOTUS.line. I'm then going to use the function ggplot to map it. So I'm going to say using the function ggplot on the object SCOTUS, and I'm going to use the AES function then to map what variables I want to use on it. So if I go back and I look at my SCOTUS, I have a few variables in here. I have poll ID, date, pollster, yes, no, alt, personal, yes, personal, no. So what I'm saying here is using, and unfortunately, we're just going to be using the object named SCOTUS, but with the AES, we're going to use the date variable and the percentage yes variable, not percentage yes. So these are the two variables we're going to look at in our plot. So if I create a new object, I call it SCOTUS dot line. And then I use my assignment operator and I do ggplot. We're going to use the SCOTUS data set that we have loaded up. And we're going to say AES, and we're going to do the date variable. And we're going to do the percentage yes variable. And once I run that line of code, I should now get in my environment a SCOTUS.line object with a list of 9. And if I call that object now, it'll open up a plot down here in my miscellaneous pane. And I'll have two variables in there. I'll have percentage yes and the date. So go ahead and run this or enter in this line of code. And then when you're ready to move on, go ahead and raise your hand. And if you have any questions, feel free to unmute or ask in chat.
Isn't it supposed to show like a line graph? Because my plot environment is blank, like
That's a
totally blank.
great question. It should be blank right now because we have two layers in there right now. We have the data set that we are using, and we have the variables that we are using, but we haven't told yet the shape that we want it to take. So it doesn't know its shape right now, so it's just going to give us a blank graph. But we're going to see here we have the parameters of both variables, our y-axis and our x-axis. We just next we're going to give it a shape, so it knows how to put the data in.
Okay. Thank you. But mine isn't showing the yes on the left side and date on the x-axis. It's just blank, like totally blank. And the variable, the environment is showing list of 11, not list of 9.
So did you run this line of code and then this line of code?
Yes.
Do
But
they?
I'll trace it again in case I missed something. Oh, okay. I see. Thank you.
Yep. Yep. Again, remember, it won't run until we tell it to run. So nothing will save until we actually physically hit the run button or hit Control Enter. And again, when you're ready to move on, feel free to raise your hand. Or if you have any questions, feel free to ask. Okay, looks like most people are ready to move on, so we can go ahead and lower our hands. So the third thing that we need then to create a plot. So we just need three things. We need the data, variables, the shape. So the third thing we need then is the shape of the object. And we call the shape with the geom function. And again, this is where these data visualization cheat sheets from ggplot are really helpful to see, okay, so if I want to create a line graph, what are my options for creating a line graph? And you can see right here, there's the line graph. There would also be geom.smooth will also allow you to create one. So if we go ahead and we take, so this next part is the uniqueness to creating a plot within our code. So the first thing we'll need to do is we'll need to call the object that has our data and our variables set into it. So they are both stored in this SCOTUS line. And then we are going to start to piece together the next layers that we want to add to it. So the next layer we're going to add on top of those are what the actual shape is going to be. So if I add in here geom underscore line and then parentheses, which is the function for adding a line graph, and I go ahead and run that line of code, we now have the graph for SCOTUS approval. Sorry, the data visualization plot for SCOTUS approval over that. And that is all you need to create a graph. Is it a pretty graph? No. Are there ways that we can clean it up? Yes, and we will go through and show you that. But let's go ahead and in your own code, just go ahead and paste the SCOTUS line together using the plus sign with the geom line. And run that line of code, and it should visualize that. And once you're ready to move ahead, go ahead and raise your hand. Okay, you can go ahead and lower your hand. So the next thing we'll talk about then is how do you further customize your graph outside of the bare bones parameters of the data, the variables, and the shape. So first thing we'll talk about is adding color, size, or transparency into it. And we're just going to look at color and size first with the line graph. So if we want to change anything that is going on in our shape, we can add arguments within the shape that will say, hey, this is what I want it to look like. So the first thing we could do is we could add a color in there. So if I go, and if you hit tab, you can actually see what's available to you. So if I say color equals, and I'm just going to change it to coral, you can add colors in multiple ways. You can add a name of the color. If it has it within there, you'll see that you are correct, but because it will add the color in. You can also do hex codes, RGBs, whatever you want to for it. So if I say within here, I'm going to add the argument to the geom line shape that I want the color of this line to be coral. If I go ahead and run that, it'll change it to a coral color. We can also say, hey, I want the size of this shape to be bigger. So right now our default is 1. If I change it to 2, we got a little bit of a thicker boy. If I change it to 5, we'll have a really thick boy. So go ahead and work with trying out your shape and your size and your color with your line. Again, you can add coral if you want to add coral. If you want to add a different color, you can try that out as well. And then play around with the size. And when you're ready to move on, go ahead and raise your hand. And while you're doing it, I'll talk a little bit about color as we are customizing our shapes. One thing to note about color is there's 2 ways in R to enter color in. There is either the color argument, which we used here, and that will be primarily for strokes and lines. So if we start talking about a box plot, the stroke will be the outline of the plot. Or when we talk about line plots, the actual line of the plot will be the color. The other way that we can enter color is the fill argument. So fill will be, if we think about a box plot, the fill will be the actual box itself, not the outline for it. So just things to think about as we are customizing. And again, when you are ready to move on, please raise your hand. And if you have any questions, please let me know. Okay, you can go ahead and lower your hand. We will look at transparency later. The next thing, though, you might want to start thinking about is how is your plot labeled? So right now, by default, the variable, by default, a plot will have no title, no captions, and the axes will be labeled with the name of the variable within your data set. So per yes and date, exactly how they are labeled there. We can go ahead though and change the labels in in um in our plot by using the labs function. So if I take, and let me start entering. So if I add another plus sign to the end of geom line and I add in labs, so labs will be the function that allows you, or the layer that allows you to change the labels around. If I hit tab within the argument section, within the parentheses, you can see the various labs that you can add to it. So I could add title, subtitle, caption, tag, alt title, so on and so forth. I'm going to go ahead and add a title to it, a subtitle to it, a caption, and I'm going to change the Y variable and X variable. You will need to separate each one of these arguments with a comma after it, and you will need to put the names within parentheses or within quotation marks. So I'm going to say labs, I'm going to add title equals SCOTUS approval, comma, subtitle equals YouGov poll, and then I'm just going to add X and Y. X will equal, let's do Y first. Y we're going to change from per percentage yes, we're going to just call it approval. And then date, what we're going to do is right now it's labeled as the date variable, but any person that looks at this axis can say, oh, it's a date, right? It's showing dates at the bottom. So if you want to remove a label from it, if you type X equals null or Y equals null, it will just remove the label. So it will not be labeled anymore. And if I go ahead and run this line of code, we now have a title, a subtitle. We've changed percentage yes to approval, and we've removed the date label. So go ahead and add these labels into your own plot. And when you are ready to move on, raise your hand. And if you have any questions, please feel free to unmute or ask in chat.
If you want to change the background from the box gray to just white or, transparent, can we also do that?
Yep, we'll get to that.
Awesome. Thank you.
Yep. Okay. You can go ahead and lower your hands and we'll move along. Okay, so based on that last question, this is what we'll actually get now. We're going to get into themes. So themes will customize how your plot looks. There is a bunch of built-in themes, which we'll look at first. But within it, you can also then, you have the ability to even micromanage the built-in themes even more. So to add a theme to it, one thing I will also mention really quickly as we are doing this, so I am entering on each line. This is not necessary. You could go horizontally with it, but I just think it looks a little bit easier for everybody to see what's going on with the code. So first line is the shape and any adjustments we've done to it. And then the next lines down are the labs, with each lab on its own line, just so you can see what's going on. So after the labs, we'll add another plus sign, and then we're going to add a theme into it. So if I start typing in theme, in RStudio, you'll see that there'll be a bunch of themes that come up. We have theme black and white, we have theme classic, theme dark, theme get, theme gray, so on and so forth. These are built-in themes within ggplot that you can add to it, and it's just usually a lot of it is choosing which one you like. So if I do theme minimal, it will remove the gray background and it will just have gray grid lines. Let's see. One of the crazy ones is theme void, which I believe removes everything except for the shape and the titles. So go ahead and in your own in your own code, play around with some of these themes that you have. Again, you'll see them if you start typing in theme underscore, you can see every one that is available to you. So try out and just kind of, like I said, it's one that you just kind of learn which ones you like. I personally like minimal. And then once you're ready to move on, go ahead and raise your hand. And if you have any questions, feel free to unmute. Okay, looks like we're ready to move on. You can go ahead and lower your hands. So the next thing we'll talk about then is those are built-in themes. They will put in components that they have kind of rendered together and what they think looks nice. But you can really customize that even more on your own if you want to, using the themes function. Now, this is a little bit more micromanagey, and a lot of the time I don't really play around with it, but just so you know that you have the ability to do it. Within it, you can see all the various aspects of the plot that you can change around within the theme element. There's a couple parts to it though. With it, you have to specify what you want to change. So, for instance, if I want to change the plot title size, I have to say the element text within the argument is what I want to change. So you'll have element line, element rectangle, element text are all the various ways that you can change it. So with this here is I'm going to say I want to change the title of the plot. And I want to make it a size 20 instead of the default, and I want to change the color to navy. So if I go into my code and under theme minimal and theme, I say plot dot title equals element underscore text, and I say size equals 20, color equals navy. Then I run that line of code. it'll change it from to a little bit bigger of a font, a little bit bigger of a font, and I can show that even more if I change it to 40. These are pixels, so it's 40 pixels, similar to what you're used to if you work with Microsoft Word or any other word processing. And you could do that with plot title, you could do that with plot, subtitle. Right, whatever you need to do. You could do it with access title, so on and so forth. So go ahead and play with the theme and see if you can change around the elements of the title or the elements of the subtitle if you want to. And when you're ready to move along, go ahead and raise your hand. And if you have any questions, please feel free to unmute and ask.
I have a question.
Yeah.
So we just modified the plot title by changing the size and the color. What if we want to modify many things within the same um on the same line basically? So for instance, we want to modify the x-axis such that there's a black line on the x-axis towards the left, the extreme end of the axis, and then on the y-axis as well. I don't know if that makes sense. So instead of them being just blank, we want to put like one line running from top to bottom and then another line from left to right on the axis.
It's a one by one, unfortunately. So it's not like a
Okay.
bulk thing that you can do with it.
All right. Thank you.
And again, when you're ready to move on, just go ahead and raise your hand. Okay, you can go ahead and lower your hand and we can move on. So the next thing we're going to talk about then is scaling your plot. So by default, uh, um, by default, R will look at your data and it'll give its own scaling, what it thinks is a good scaling for your axis. So right now it looked at the approval percentage within our data, and it said about a range of about, looks like 55 to about 45 or 35 is where most of this data can easily be viewed. It's also looking at the dates, and it's going about every 3 months, we'll put a date break in there. However, using the scales element within R, you can actually rescale any axis within your plot. The one we're going to look at as an example is the scale X date. So this is saying right now our scale the X axis, and it is a date value that we are looking at. With date values, there is a common programming format that is called strip time for scaling, for notating dates within it. This is the same whatever language you are using. So if you are using Python versus R, it is going to be the same strip time elements that you use for it. And all you have to do is go to their website and see how the names will be put in there for how you're doing it. So if we are looking at, let's say we want to do abbreviated month name or full month name, it'll be percentage B or percentage capital B. And then the day, I believe, is under percentage lowercase d. And then year is probably Y. Yep. So right now, what we are looking at within it is looks like percentage lowercase b and percentage upper score Y. If we wanted to change that around, we can do that. We can also say how the date breaks. So right now it looks like it's a 3-month break. Let's say we wanted to change that to a 6-week break and we wanted to put a new date label in there where we have uh, abbreviated month and then the day of the month. We can do that with the scale X date. So if I add another plus sign and I say scale underscore X, and you can see there's a lot of ways that you can scale X. If you have a continuous variable, date, so on and so forth. So I'm going to do scale X date, and I'm going to say, I believe, date breaks. Yep, date underscore breaks equals, and I'm going to put in 6 weeks, and then comma, and I'm going to do date underscore labels equals, and percentage B and percentage Y. Right? No, percentage D. And then I run this line of code. So now we are getting a break every 6 weeks. And the way we are seeing it is we are seeing abbreviated month and then day of the month. So if I did Y, I would put in the year as well. So go ahead and try out the ScaleX date. If you have any questions, let me know. You can change around the break as much as you want. So if I did 1 month, I could do 1 month. And when you're ready to move along, go ahead and raise your hand. Okay, looks like most people are ready to move on. So right now we are looking at a line graph. With line graphs, we also have the ability to use the smooth shape instead of the regular line shape. And what the smooth shape will do is it will reduce overplotting within it. So we can either use this using the lowest method or the linear regression method. And to do that, we just go ahead. And right now where it says geom line, we're just going to go ahead and change that to geom smooth. Run that line of code. And by default, it uses the lowest method. And you can see it's just an easier shape to see within it. So it minimizes the overplot within it. So that is something particular to line graphs. You either have the option of the lowest or the smooth or the regular line graph. And this is an example of fill as well. So you have color and fill within it. Once we are done with our plot, we can go ahead and export it. There's a few ways that you can export it. If you are running a code that you want to export the image over and over based on changes that you make, I would say to use the ggsave function to do that. So if we go ahead and put in the ggsave function, we'll just put in the name of what we want to call the image along with the file type. So PNG, we could do JPEG, so on and so forth. The size of it, this is in inches, so it's going to be a 6-inch width and a 4-inch height, and the number of points per image. So we're going to set that about 3. The DPI we're going to set to about 300. 300 is a pretty standard set for a good image within that. And if I go ahead and run that line of code, I actually realize that I forgot to delete it from the last time I did that. Delete. So we'll delete it. We'll refresh. So right now it's not in there. If I go ahead and run that line of code, and then I refresh, we should now have a SCOTUS approval.png. And if I go ahead and go into my file folder, and this is just because I have but this is all white. I just have my paint so weirdly, which I gotta fix one day. The other way that we can export it is more of a GUI export of it. If we go into our plots, if we go into our plots tab, it has a little export here. So we can save it as an image or a PDF, or we can copy it to a clipboard. So if we're using Word, for instance, start a new document, and we're just copying and pasting it into Word, I can copy the plot. I can go into Word. Oop, what happened? I don't know why it's not copying right now. Oh well. That's one way you could do it. It's not working on my computer for some reason, but that's okay. You can also just save it as an image. So it'll by default save it to your working directory, but you can choose a different directory if you want it. You can, within this, adjust the width and height, and you can maintain that aspect ratio. You can choose what type of file you want to save it as, and you can change the name of it around. So this is more of a GUI interface for doing the same thing that we are doing here. And you can also save it as a PDF as well within there. Okay, are there any questions about exporting your file? Okay, next thing we're going to do then is we are going to try this out one more time on a histogram. So the histogram geom will allow you to set the distribution of a continuous. So you double our numeric variable within it. So first thing we're going to do is we're going to load up a new data set. We're going to call it demo. And we're going to read underscore CSV, the demographics.csv. Load that up, and then we're going to call it. And we're going to see within here, we have a bunch of numeric variables. We have age, we have address, we have employment. The rest, if I cleaned it up, these are all categorical variables. We have car, and we have income. So go ahead, load up that data set. And then we're going to create a new object. We're going to call it demo.hist. We're going to ggplot. We're going to say use the demo data set. And then we're going to set the variables with the aesthetics. And we're going to set, let's see, what are we using? We're going to just set it to age. So with the histogram, we only need one variable set, the X variable. One thing I forgot to mention with the aesthetics is by default, it assumes within the argument aesthetics It assumes the first you put in will be the X variable and the second you will put in will be the Y variable. You can also just say X equals age or Y equals whatever. And then once we run that, we should get um, a new list with 9 elements in it. Go ahead and do that. When you're ready to move on, go ahead and raise your hand. Oh, and then we'll create the histogram. So demo.hist plus geom histogram. No. And when you're ready to move on, raise your hand if you have any questions. Please feel free to ask. Again, once you have it loaded up, you should see the histogram down here. Not pretty, looks like a big blob, kind of, as most histograms do. You can go ahead and lower your hand. Next thing we're going to talk about then, within histograms, one thing that you can do in histograms is you can bin values. So the idea with this is, right now, if we look at our histogram, it's saying this is everybody that's 18, this is everybody that's 19, this is everybody that's 20, 21, so on and so forth. We can put the ranges of our continuous variables into essentially bins. So almost kind of like create a categorical variable. So the first bin will be 18 to 25, and the second bin will be 26 to 32, or so on and so forth. We can do this within our bins shape with the bins argument. So we can do this in one of two ways. We can either say the range that we want the bin. So this will be 10. So this will say, I believe that the age in this data set starts at 18. So the first bin will be 18 to 28. Second bin will be 29 to 39, so on and so forth. The other way we could do it is we can say the length of, this first one is setting the number of bins. So this will say, take the range of the data, create 10 bins, and however that equally falls out, throw the people into those bins. The second way is we can say the length of the bins. So this will say the range one that I firstly described. So if I say bins, keep hitting this there. Oh my. So now this now has 10 bins in it, and we'd be able to see this a little bit easier once we clean it up. The other way we can do it is the bin width. So we'll say bin width equals 15. So that will say the range now is 18 to, looks like about 30 something. So it essentially created 5 bins within it. Once you're ready to move on, go ahead and raise your hand. Okay, you can go ahead and lower your hand. So let's clean this up a little bit. Let's actually change the bins. We're just going to have bins equal 25. So this is going to have 25 bins within it. And then let's start adding color. So with histograms, the color is going to be the outline of the histogram. So I'll have that equal coral. And then the fill is going to be the fill of the histogram. So I'll have that sky blue. And then we're going to actually set the transparency of this one. So I'm going to say alpha equals, the alpha range will be in between 0 and 1, where 0 is completely non-transparent and 1 is fully transparent. Or does it go the opposite? Let me see. Yeah, sorry, other way around. 0 is fully transparent and 1 is non-transparent. We're going to set it to 0.5 though. So go ahead and run that, and you can see when you run it, you can see that you can actually see where these bins are now a lot easier. And then again, the outline is going to be the coral color because we set that with coral, and the fill is going to be the inside of it. And then we can give it a new theme too if you want to. And when you're ready to move on, go ahead and raise your hand. Okay, it looks like most people are ready to move on, so we can go ahead and lower our hands. So the next part we're going to talk about is an important part to understanding how your code works. And that is, as I've mentioned with other things that we've done in R, the order of elements really matters. So within creating a plot, that is also true. So the order that the elements appear on your plot is dictated by its position in the code, where the first elements of the code appear at the bottom and the last elements appear at the top. So to explain this, you can think of it as if you were taking like sheets of sheets of transparent paper with elements of a plot on it and just layering it over and over up again, where the top ones are the most visible and the bottom ones are the least visible. We're going to combine this with the fact that you can also add multiple geoms into your code. So let's say I want to add a reference line into this code where maybe the average age of a person is 40. So we want to see that reference line in there. So I can add in to my code after the geom histogram. I can add another geom and we'll call this geom V line. There's geom V line for a vertical line or geom H line for a horizontal line. And I'll have the x-intercept equals 40. And we'll say color equals navy. And we'll say size equals 3. Now run that line of code. Now, because because right now the geom histogram layer is underneath the geom v-line layer, you can see clearly that this line is sitting on top of our histogram. If I change that around, if I change that around, and I put the geom line first, you can see now it is clearly sitting underneath it. So as you start layering up your plots, understand that this first line right here is going to be the very bottom of your plot. And this line right here, the theme, is going to be the top of your plot. Are there any questions on that? Okay, we can go ahead and move on then. I won't have you worry about putting in the V line. It won't be necessary for this next. The next thing we're going to show then is the idea of faceting your plot. So what faceting will allow you to do is if you have a categorical variable, you can pull out and create subplots based on the categorical variable. So what we're doing here, you can either do it with a facet wrap, which will wrap the plots, like this, or you can do a grid where you tell it, this is the grid size I want. I want 3 rows, I want 3 columns, so on and so forth. So if we look at our demo, we go back and we look at our demo data set, there are a bunch of categorical variables. Again, if we would have cleaned this up, we would have said this is the categorical variable, this is the categorical variable, so on and so forth. But we can see right now we have income category, we have car category, we have education, that these are all categorical variables. So what I want to do is I want to plot this histogram based on the income cat. And we're going to do that with a facet wrap. We're going to set the facet to equal the variable income category. And we're going to say I want 3 rows within that. So however it wraps out, it's got to have 3 rows. If I go ahead and run that line of code, now you can see, well, that didn't matter because there was only 4 of them. Now you can see that we have right here a histogram for the people whose ages are within the 25 to 49 income category, 50 to 74, 75 plus, and under 25. So it makes sense, right? Even though this is all made up data, it makes sense that the people that are under 25 are typically going to be younger, and the people in the highest are going to typically be older. So another way to show your plots specifically based on a categorical variable is to use the facet option. In the interest of time, we're going to skip the bar graph. Again, one thing that you get when you downloaded the lesson plan is you're going to have both the lesson plan in a PDF format. So if you want to go through the bar graph on your own and kind of see what is going on, you have the PDF for it, and you also have the RMarkdown file for it. So you can actually work through all these on your own as you see fit. The next thing we're going to talk about, though, is creating an RMarkdown file on your own. So right now we've been working with an RScript file, and an RScript file interprets everything that you are putting into it as code. Our Markdown file is a user-friendly markup language that allows you to combine text, code, and output into a single document. You can either do this with an R Markdown file, which is the older version. They've recently added the Corto files. So if you want to use that, you can also do that as well. These are also the documents that if you are interested in creating interactive dashboards, this is where you would go to create an interactive dashboard through the Shiny version of it. So you can see, well, what would I use this for? Well, you could write up your article directly into and be integrated within your code for it. You can also create presentations. So if you're presenting the analysis that you can have your code built directly into it, and it will dynamically update wherever you did. And you can also make, again, dashboards with it. So if you wanted to publish a dashboard of your data, this is what you would do to use it. It also allows you to make websites with it as well. To get started on one, you just go into File, New File, and then you can see you have Quarto document, Quarto presentation, or RMarkdown file. I'm just going to do RMarkdown. It'll start you off with the basic metadata of it. What is the title? Who is the author? When was this created? You can see over here on the side that if you want to create different types, it's by default a document. But if you want to create presentation slides or Shiny for your interactive document or interactive dashboard, you can do that as well. You can also set by default how it will render out. You have three options for rendering: HTML, PDF, or Word. You can change how it renders at any point, so you are not locked into how it renders. You're going to see first off at the top, the metadata for it. Right now, we just have title, author, date, and output method. So this is going to be nothing that anybody else sees. You can add additional things into what is called the YAML header. So you can add things like if you were writing an article and you want to give thanks, you can write in who the author is, what their affiliation is, an abstract of the article, any keywords that need to be put in there. And it will render out however you tell it to. So this YAML will render out in the article like this. And then within it, you can see a bunch of the structure and themes that you can set for your YAML within the themes. So if you want to do a particular theme within it, you can see what is available to you. Now, as you start to mark up your document, you can do it with Markdown language. So Markdown, for example, is if you want to set a header, it is one £sign or hashtag. You can do this either in code or you can do it within a WYSIWYG within the visual tab. So this will just give you, if I want to set a header 1, I can do it very easily with the WYSIWYG. If I want to create bullet points, if I want to create an ordered list, if I want to add a link, a figure, if I want to change whatever, any of this information, I can do that. If I want to insert things, I can do that. Or if I want to create a table, I can do that. If you are just getting used to Markdown language, my suggestion would be to use the WYSIWYG, but if you have all the Markdown language within it, within the documents that you have within the lesson plan. So if you want to look through them and see how to code Markdown language, you're available to do that. Now, the big thing about this is everything that you type in, everything that you type into this will be interpreted as natural language. So there's no running of a code here. If I try and run this, it won't have anything to run. What you will do with Markdown documents or Quarto documents is you will add code chunks into it. And you add the code chunks using this drop down as like a little C up here, and you can choose the language that you want to interpret it as. So this is something that if you are working with somebody who uses Python language and you use our language and you are collaborating on a document, you guys can actually both use Python and R in the same document together. But for instance, let's just do an R code chunk. You're going to get a few things within this. So everything between these three backticks and these three backticks will be interpreted as code. So if I do so if I do 2 plus 4, and I run that line of code, it's going to give me an output. And again, it outputs in the console, but it also will output into the document itself. So this is something that if you were running visualizations like we just did, it will output the actual visualization within there. Now, there are ways that you can set how the chunk is outloading. First thing is you can give the chunk a name. So now if I look through my table of contents down here, I can see that I have a chunk here that is called addition. You can also say things like, I don't want to show warning. So if you get a warning message, like you're loading up a file and it's got a depreciation or something like that into it, and you don't want to show that into the final document, you can say don't show it. If you open up something that has a message, so if you load up Tidyverse and it has the message that says you loaded up and you don't want that to show in the final document, you can turn that off. You can also say how the output is rendered in the final document. So if I want to say, show only the output, don't show the code into it. Now, when I render this, it will only show 6. It won't show the person who's looking at it, the 2 plus 4. You can also say show code and output. So if you want somebody to see the code within the document, you can do that. You can say show nothing but run the code, or you can say show nothing and don't run the code. So there'll be instances that you may not want to run the code within it. Once you are done setting up all your code chunks and setting up your documents, you can then render the document. So in RMarkdown, it's called knitting the document. In Quarto, it's called rendering the document. And this will just render it in whatever format you want, PDF, Word, or HTML. So if I look at my file, I now have an example. So now I have the rendered. Let me just turn all these off. So this is just another way that you can run this. So let me grab it really quickly here. So I wanted to put my histogram in there. Yeah, that's not finding it. That's okay. So for example, like the lesson plans for these were made with the histogram with that RMarkdown file. So again, it's just another way for you to use RStudio to as kind of your one-stop shop. So if you prefer using Microsoft Word, typing out your article within there and copying and pasting the output of your code into there, that is one way you can do it. You could also use an R Markdown file or a Quarto file to do the same thing in a non-proprietary fashion. Again, it is also the way that if you are interested in creating interactive dashboards, it is the file types that you use for it. I would suggest if you are interested in interactive dashboards, that you use a Quarto. Okay, it is 5 o'clock. So that is the end of our session. This is the last session for the R workshops. If you are interested, we are offering them again in October, and you can find under the workshops listings, you can find the available dates that we have for that. We are also offering a GitHub on Thursday if you are interested in that. If not, if you have no questions, you can feel free to leave. I will stick around though. If anybody has any questions, I'm happy to answer. Again, my name is Matt Steele. If you want to get a hold of me, it's an easy Google search, Matt Steele WBU. And you can find this nice, shiny, happy picture of me, not looking like I'm having a stroke at all. Thanks, Jeff. And I will send the recording out probably Friday. We'll see.